All right, let's take a look at how these modeling tools can help optimize a process. What you see behind me on the screen is a simplified process. It's for demo purposes only. It's not a real process, but it helps to illustrate a lot of the principles and the ways we use process modeling to improve process performance. The overview of the process is as follows. We take a raw material, slurry it up with water, preheat it, pass it to a reactor. In this reactor, some of the raw material transforms into our soluble product. There's also a side reaction which consumes some of our product and converts it to an insoluble byproduct. After some heat recovery, we're able to separate our product, which is soluble, from our unused raw material and our byproduct, which are insoluble, in a simple filter. So that's what we see here. The filter cake, which is mostly unused raw material and byproduct, is still wet, and that held up liquid contains product. To increase yield, then we pass that to a second recovery filter. In this filter we just wash the cake with water. Like I said, this improves yield. So the clarified liquor from the first and second filters passes to an evaporator feed tank. After preheating, we need to evaporate this. We concentrate it up to final product concentration, cool it for storage, and put it in the product tank. Like I mentioned earlier, this type of model is not just simply a polynomial fit to data. This is built from mass energy balances, physical property calculations, transport equations, that sort of thing. Gives us a couple things. One, it lets us see things that are not measured. You can see that I can click into any stream or any block here. I can get compositions, flows, etc. Really, this is just closing mass balances, but it's very nice for reconciling your data, coming up with one consistent set of information from which to make decisions about your process. We can layer on calculations as we wish. In this case, we've built some other calculations, if we summarize them in a table here, related to the economics of the process. So given current product sale price, raw material cost, cost for natural gas, say for a boiler, other utility costs, we can calculate things related to the economic performance of the process. It's kind of an eye chart, certainly not visible in this demo, only slightly better, but I will switch over to an Excel spreadsheet I've prepared. We can copy and paste over that. So let's just dig into the reasons for the components of our processing costs. All right.